Hi, engineers. You're in the live interview, and the interviewer points at an array and says, remove this value in place. Order can change. Return how many are left. Most candidates overthink it, but you won't. Today, we're going to solve remove element coding challenge. So, here's the problem. Given an integer array nums and an integer val, remove all occurrences of val in place. The order of the elements may be changed. Return the number of elements in nums that are not equal to val. Change nums so the first k elements are the elements that are not equal to val. The remaining elements do not matter. First, let's rephrase it in plain English so it really clicks. We will keep only the elements not equal to val, place them at the front, and return how many we kept. Everything after that count can be anything. Now, let's set up 3 example inputs so we can test later. We create a variable named nums1 and set it to the list of 3, 2, 2, 3. Then, we create a variable named val1 and set it to 3. Next, we create a variable named nums2 and set it to the list of 0, 1, 2, 2, 3, 0, 4, 2. Now, we create a variable named val2 and set it to 2. Next, we create a variable named nums3 and set it to the list of 1, 1, 1. And we create a variable named val3 and set it to 2. Let's start with a beginner-friendly approach, forward right pointer. We create a function named removeElementWrite that takes 2 inputs named nums and val. We will return a number. Inside the function, we declare a variable named w and set it to 0. W will be the next right position for a kept element. Next, we start a for loop. We declare a variable named I and set it to 0. The stop rule is I is less than num's length. The update is increase I by 1 after each round. Inside the loop, we create an if statement. The condition is nums at I is strictly not equal to val. Inside the if block, we set nums at w to nums at I, and then we set w to w plus 1. After the loop finishes, we return w. This w is the count of kept elements, and the first w positions of nums now hold those kept elements in their original order. All right, let's test our beginner version. We write a console log of removeElementWrite of nums1 and val1. Then, a console log of removeElementWrite of nums2 and val2. And a console log of removeElementWrite of nums3 and val3. When we run it in the terminal, the expected results should be, for nums1, k equals 2. For nums2, k equals 5. For nums3, k equals 3. Now let's proceed with the optimized approach. Minimize writes by swapping from the end. Order may change, which is allowed. We create a function named removeElementSwap that takes nums and val. We will return a number. Inside the function, we declare a variable named I and set it to 0. We declare a variable named n and set it to num's length. This n is our current effective size. Next, we start a while loop with the condition I is less than n. Inside the loop, we create an if statement. The condition is nums at I is strictly equal to val. Inside that if block, we set nums at I to nums at n-1, and then we set n to n-1. We do not increase I here because we must recheck the swapped-in value. We create an else block for the other case. Inside the else, we set I to I plus 1. When the loop finishes, we return n. This n is the count of kept elements, and the first n positions of nums contain those elements in any order. Let's test the swap version. We write a console log of removeElementSwap of nums1 and val1. Then, we write a console log of removeElementSwap of nums2 and val2. And we write a console log of removeElementSwap of nums3 and val3. When we run it in the terminal, the expected results should be the same. For nums1, k equals 2. For nums2, k equals 5. For nums3, k equals 3. So, here is the interview summary. Say your plan first. I can use a forward right pointer to keep order, or a swap from in pointer to minimize writes since order may change. Always state complexity. Both are O of n time, O of 1 extra space. Call out pitfalls. Do not advance I after a swap. Return the correct count. Do not rely on values beyond k. And a soundbite. Stable right pointer if I care about order, swap from end if I care about fewer writes. Both in place, both linear. Now you're 1% smarter. The cheat code is consistency, so keep boosting your brain. Make it your daily routine, and you will nail your next interview. Same rhythm tomorrow at Code Crack Interviews.